Rohit, can we start?
Yes, sir. So now I am requesting Damija ma'am to kindly start this webinar, please. Over to you, ma'am.
Thank you very much, Mr. Rohit. And good afternoon to all of you. And welcome, Mr. Sachin. And thank you for accepting this invitation. So this is a celebration, or this is a webinar series which we are organizing as a part of the Azadi Ka Amrit Mahotsav, which is an initiative by Government of India to celebrate 75 years, commemorating our 75 years of independence, commemorating the glorious history of our people, culture, and achievements. This event is dedicated to the people of India who have been instrumental in bringing India to the level at which we are, and also contributing to what we are doing further. Recently, we have seen the launch of the Chandrayaan, we have seen the mission to the sun, and of course, the G20 was one event which has really brought pride to each and every Indian. So this is how India is progressing further. We are going to be a big economy, and this is what the event says, that we are commemorating all the efforts put by all the Indians to reach this level. In Skill Council, what we decided was that we should have, in this event all over the country, many events are being, held. Like you have exhibitions, you have talks, you have webinars, you have even awareness campaigns. So in Skill Council, we thought that we should organize a series of webinars, and we should interact with learned people, learned experts about the different sectors in which we are working. Like we are working in environment, renewable energy, waste to energy, water management. Of course, the carbon market is one area where there is a lot of work to be done, and we are there. We are also pursuing activities in that. So we decided we should have interaction with, invite speakers, invite learned experts, and have interact with them. And we should learn from them and also see what input we can get from them so that we can better our activities. So today we have hydrogen, and green hydrogen is something which is a talk of the town, everywhere, or in fact, it is a talk of the globe. So this is an area which is being, seen as a major contributor to what all our emissions or what all our goals have been set for achieving net zero by 2070. So the government has already launched the green hydrogen mission, and we in Skill Council also have been very proactive. We have developed qualification packs, because skill development in manufacture, production, in utilization, it has to be a parallel activity. And in Skill Council, we have developed qualification packs for the job roles, for production, for operation, and we look forward to organizing trainings so that we can have skill development, and there should be no dearth of skilled workforce for taking up this mission. So in this context, I would like to thank Mr. Sachin, who has accepted our invitation and who would like to, tell us more about this area, about how the opportunities in green hydrogen can be exploited and how we can build skills. What are the skills, how we can take it further. So I welcome you, Mr. Sachin, and I again thank you for accepting our invitation to join us in this webinar series, which is now the 94th. We are holding, we plan to do 100, and maybe after that we may revise the format, but we will continue to interact with our participants who are regularly attending our series. So once again, welcome to this, and I request Mr. P.B. Singh to kindly introduce Mr. Sachin Torne. Thank you very much.
Thank you, ma'am. Thank you very much for the welcoming the speaker and audience. Good afternoon, everyone. I'll welcome you all to the 94th series of the webinar. The Skill Council for Green Jobs is organizing a series of webinars to celebrate Azadi Ka Amrit Mahotsav as a part of India's celebration of 75 years of independence. In this series, SCGJ is inviting eminent and learned speakers in different sectors on sustainable development, renewable energy, and waste management, so as to deepen the understanding of recent development in these sectors. The first in the series was launched on 24 September 2025. Today we have Mr. Sachin Torne, a very experienced learner, distinguished speaker, who will be sharing his expertise and experience on building skills for ex- exploiting green hydrogen opportunities. I would like to share her brief profile with all of you. Mr. Sachin Torne is an electrical engineer with an MBA with over 35 years of versatile experience spanning the electrical engineering industry, information technology enabled services, and edutech sectors. Currently, Mr. Sachin is lead the green energy skill development initiatives at Tata Power Skill Development Institute. He is a great advocate for the widespread adoption of green hydrogen, underscoring its crucial role in the sustainable energy solutions. His position in strong commitment for nurturing the next generation of green energy professionals through innovative skill development initiatives. Mr. Sachin visionary outlook drives innovation towards a greener, more sustainable future in the realms of energy. Now I am requesting Mr. Sachinji to start the presentation. Over to you, sir.
Thank you so much, Mr. Singh and Dr. Damija. Thanks for the invitation out over here in SCGJ for this webinar series. I will share my screen and start with the presentation. I just confirm if my screen is visible.
Yes, yes, please.
So I feel really fortunate enough because this generation has seen the IT revolution, the service revolution, and now the clean tech revolution. So I think we have been the blessed generation who is really who is able to witness the changes that have been happening. And in this today's session, we would be looking at how do we really exploit the opportunities that have been thrown to us by green hydrogen. And as Dr. Damija talked about, green hydrogen is the talk of the town. It's a toast of every discussion that's happening in clean tech area. I think there's a lot to be done, and we are at the same stage we were in mid-90s when the IT revolution started. So I think we will have to do it once again the way we capitalized on the opportunities, not just the national opportunities, but also the global opportunities that were presented to us. So in this presentation, there are just 3 points that we'll be talking about. We first look at what are the opportunities that are there. So understanding what green hydrogen opportunities are, then how do we really, what kind of workforce would be required? What kind of skills would be required to really capitalize or exploit these opportunities thrown to us by the green hydrogen initiatives? And how do we go about preparing the workforce? So these are just thoughts that I have, which I would like to share with you. And I'm sure there would be a lot of discussion that would happen, and there would be a lot of questions that you will have. And let's keep this session more interactive so that we can share knowledge, we can gain some knowledge, and it becomes an interesting session. So when we look at green hydrogen, everyone has been talking about it. We don't get into what is green hydrogen, how it has been produced, but we rather look at why we are doing it. So if we go by the World Health Organization reports, we said that 99% of the world's population is breathing polluted air. And well, we can always say we've seen the scenes in Delhi, Mumbai, where the pollution levels are so high. And this is a truth. And this is something, this is a man-made kind of a disaster that we are living in. And do we really want to go ahead and leave this kind of a planet to the next generation that is coming in? It's not their fault anyway, because it's the abuse that was done by the previous generations, which they would have to pay for. So this is one of the truths which is there. Secondly, if you look at the Bloomberg New Energy Finance report, they say that if you have to really control global warming, the temperature rise should be less than 1.5 degrees Celsius. And it's difficult to do it. You have seen what kind of issues that we are facing because of climate changes. We are looking at these floods which are coming up. We are looking at the every time we said that no, this summer has been worse than the previous summer, and that's going to keep on continuing as long as we really keep adding the greenhouse gases to this atmosphere. So if you have to really do all those things, Erna says that 90% of the world's electricity should come from renewables. Now, renewables in terms of solars, wind, hydro. So that is, we're just talking about the electricity part. There's another part, which is a total energy consumption that happens across the globe. But at least 90% of the electricity should be coming from the renewable energies. And the forecast is that if around 18% of this is contributed to clean hydrogen, we would be able to reduce a lot of pollution and carbon emission that happens. Now, this is a CIC Energy given report, which is saying that 18% of this. Now, when we talk about 18% of it, we are talking about close to around 800 petawatt hours of energy. So that is the amount of energy expectations that the world has from green hydrogen. So it's a huge number that we are looking at. It's something which is going to throw a lot of opportunities, and these opportunities will be coming across the value chain. So if you look at what are the opportunities, there's an investment around $9.4 trillion that would be going across the supply chain. So this is an investment that will go into just green hydrogen value chains by 2015. So 9.4 trillion is a huge number, and that is where people are going to look at a lot of opportunities in all the sectors that are related with green hydrogen. And what it is going to give in return is a 800 billion kind of a revenue per year from the green hydrogen related initiatives. Now, it's a huge opportunity, just not for India, but the entire world. And especially developing countries with a huge manpower is what we need to really look at it. And we need to really capitalize on these things. And this 800 billion revenues would require around 30 million jobs. That is an estimate that is coming. So 30 million global jobs would be available in the green energy segment. Now, the majority of the green energy implementation preparedness is at different stages across the world. There are certain countries which has gone ahead and are probably more prepared than us, but there are certain countries which would probably be behind us. And there's again an opportunity because of the staggered nature of preparedness. So how do we really capitalize on these opportunities that are coming up? So India, from their part, made a commitment to the world, which we call as Panchamrit. It's a 5-point agenda, and I'm sure you all are aware of it at the COP26 UNFCCC in Glasgow. So we said that we are going to take up these 5 goals, and these 5 goals are going to ensure that we are able to combat the climate change that is going to come up, that is happening. So one of the first goal is saying that we will reach a 500 gigawatts of non-fossil energy capacity. Now, 500 gigawatts from the current around 173 gigawatts is almost a 3 times jump that we are looking at in the renewable capacity. So basically non-fossil capacity. We are saying that 50% of our energy requirements would be met by renewable. So currently we are at 43%, where we are having 43% of energy capacity coming in from renewables. We are saying that at least 50% of it will be met. So again, there's a huge jump that is required because the numbers are going to increase year on year. And at the same time, the capacity as well as the requirement goes up. The third goal is we are saying we would be reducing the carbon emission by 1 billion tons from now to 2013. Now, that's a huge amount of reduction in carbon emission. That definitely says that we would be better, we will have a better environment as compared to what we are staying in today. Third, the fourth goal is reduction in carbon intensity of economy by 45% over the 2005 levels. So when we talk about carbon intensity, is the amount of carbon emission that happens per unit of GDP. So as the GDP also increases, the amount of carbon increases. So we are saying that we will be at 45% over what was there in 2005. And finally, by 2017, we would like to achieve the target of a net zero emission. Now, this is a very ambitious target that has been set by our nation. And to achieve this, there's a lot of work that needs to be done at various levels, right from the government level to the individual levels, the industry levels. So let us look at what are the initiatives that have been taken so far. So the government set up the National Green Hydrogen Mission as Dr. Damija talked about it. So this was something which was approved on the 4th of January 2000. And they set up a very simple mission. They want to make India a global hub for production, usage, and export of green hydrogen and its derivative. So just looking at this one sentence, it completely captures the opportunities that we talk about, the 30 million jobs which are coming up and around $800 billion revenues per year. So that is something that we want to really be the pioneer in that particular area. We want to really make ourselves as the export house for green hydrogen related, maybe it's equipments, technology, manpower, whatever it is, we want to play an important role in that segment. And it is again the same thing that we tried doing it in the IT. So we already have done it once, and I'm sure we will be prepared and more aggressive this time in capitalizing on this opportunity. The second mission, which the Green Hydrogen Mission has stated, is to contribute India's aim to become Atmanirbhar or independent through clean energy and serve an inspiration to the globe. So this is most inspirational in nature, but we want to lead by example is what we are talking about. We said that we want to be a nation which is committed to clean energy, which is committed to climate change. And we are going to do it by becoming a global hub for export, for production, usage, and export of green hydrogen. And after having defined the mission, there were certain goals, targets that were set. And these were clearly spelled out, which is the beauty of this entire document which has been created, which talks about saying that we want to have 5 million metric tons of green hydrogen annual production by 2013. We want to increase our electrolyzer capacity to at least 60 to 100 gigawatts. So that is what it is. And 125 gigawatts of energy coming in from renewable only for green hydrogen. So having set these targets, we need to now work backward and see that how are we going to work on this? And what kind of work needs to be done in terms of policy decisions, in terms of investment outlays. So the government has also approved an outlay of close to around 20,000 crores towards the green hydrogen mission. And what are they going to achieve through is they're going to save around 1 lakh crores in import saving. Now, this import saving comes mostly from the crude that we import. So by going on to the green hydrogen as a source of fuel, we would be looking at a 1 lakh crore import savings. We are going to do reduce the carbon emission by around 50 million metric tons. And we are going to create 6 lakhs jobs. Now, 6 lakhs jobs as compared to the 30 million job opportunities global is a very small number. So I think when we talk about a global hub for export, I think export also involves export of manpower talent. So we should more be targeting around the 30 million opportunities and so that we should have the major pie of that pie and see how are we going to really capitalize on it. And this is going to require a lot of investment. So the government has committed around 8 lakh crores of investment in this thing. Now the government is very supportive on all these things and very committed to going and achieving this particular opportunity and saying that we want to play a major role in this one. Now, how do we really go about preparing the workforce for the 30 million job opportunities? And these 6 steps are not like rocket science. These are the standard steps that we go through and said that how do we really do that? And SCGJ has been working on many of these things, as Dr. Damija talked about, saying that they have been preparing the curriculum for various skill sets. Now, the 6 steps is first to do a thorough skill gap analysis, saying that if this is a new nascent technology that is coming up, what are the kind of skills that would be required? What would be the nature of work that is there, and do a detailed skill analysis. Once the skill analysis is done, we do a competency mapping and say that what competencies would be required for each of the skills. And based on those things, we do a curriculum design, saying that if we have to have skills of this particular type, what kind of curriculum is to be done. And this curriculum design will lead into your creation of the courses for various levels, various skill sets. And then looking at how are we going to really propagate this through various trainers. So we need to build up a trainer capacity. And then once the trainer capacity is built, we would need to decimate or implement the training. What kind of training infrastructures is required? How can we really leverage the relationship between industry, academic, and this collaboration? How can we really use it, leverage existing infrastructure to to increase the number of skilled people available in the market. And finally, looking at how do we really do a certification accreditation. The reason this is very important, the certification and the accreditation part, is because if we are targeting the global market, I think the kind of skills and the people that we are going to create from this training needs to be at a global standard. The benchmark has to be the global standard. What is best in the industry? Because if we have to differentiate ourselves and want to really leave an impression on the global green hydrogen market, we need to be committed to world-class standards from day one. We can't be saying that, okay, we'll let it do and then we go and try to build the quality. I think it has to be done from the very beginning. How do we really go about building a quality infrastructure, quality courseware, and a quality training to develop the skilled manpower that is required? So this is a breakdown which came from the Niti Aayog, saying that how are the 6 lakh jobs that are going to be there in India distributed. Now, if you look at it, it is mostly coming from the renewable energy segment, around 3 to 4 lakhs. Then it is followed by electrolyzer manufacturers who will require stack designers, project engineers, process engineers, electrical technicians, will require plant and construction commissioning skill sets. These jobs also would be more in green hydrogen plants, commissioning managers. So this is more of an overview in terms of where the jobs would come up. I'm sure there would be more details which would have been done, but this is just an overview of how the 6 lakhs jobs that have been projected are going to come in. Though renewable supply is something which is going to take up almost around 2/3 of the job opportunities, but the rest of them are more towards green hydrogen production, manufacturing, storage, distribution, and application building. So if you look at this opportunity and see that, okay, this is 6 lakhs jobs, but still there are around 30 million jobs out over there. So I think we need to even add those kind of skill sets. What are the kind of competencies that are required, both from the technical as well as from the non-technical sides? Now, this is just a map of competencies that might be required, and there would be much more than this. There's just few that I try to list down out over here. So fuel cell integration, renewable energy, fuel cell operations, electrochemistry, safety engineering, and so a detailed competency mapping has to be done to the skills that would be required to really harness this opportunity that has been given by the opportunity of the green hydrogen. So once we have the skills been done, the competency mappings been done, both for the technical and the non-technical things. So because when you are looking at non-technical, it would be on project executions, analytical thinkings, environmental impact, regulatory compliances. A lot of these things will come in where we need to identify these competencies and really weave it into the courseware that we are going to build. Because unless and until we just focus more on the technical aspects and not so much on the non-technical and the soft skills, we will not be able to produce the kind of global skill sets that that would be required. We have to really differentiate ourselves in terms of what kind of people, what kind of equipments that would be provided over there. So this is important that we really focus on defining the skill map and the competency map. I just want to share with you one of the samples which was done by the Queensland, Australia, in terms of what kind of skills would be required. Now, this is a skill map which was created by Queensland, and this was worked together by the industry, by the government agencies, and they listed all the skills that would be required at various stages. So if you look at, they looked at planning and design in terms of how do our hydrogen systems and facilities are designed, what kind of integration would be required from various systems, what kind of pipeline, storage, transport. So this is how we need to really list down all the skills that have been required. And currently they just made a list of 77. I'm sure there would be many more skills that would be required. And then once these skills have been required, the requirement has been put down and the competency map has been created, we can start mapping the competencies to each of these roles and say that if we want this kind of person, what are the kind of courses that need to be done? And that's the way we go about doing the entire skill mapping, the competency mapping, and creating a roadmap for saying that, okay, this is how we should be building our skills in the area of green hydrogen. So SCGJ has already started working on creating the QPs for various positions. And I'm sure as we move on, we'll be covering almost all the skills that have been required, and we'll keep it current by continuously looking at what are the new developments happening in those areas and getting the people to participate in building those QPs, both at the industry level, at the academic level. Now, the second step is about building curriculums. Now, when we look at curriculum, there are various stages, because first we are looking at reskilling and transitioning. There are a lot of people who are working in the energy and the power sector, in various other sectors, where green hydrogen is going to be impacting the way things have been done. So the first is to look at reskilling and transitioning, because we don't want job losses happening out over there. We basically look at what kind of curriculum design that is required today. So when we do a curriculum design for reskilling and transitioning, we look at what is the existing knowledge level and the skill level which is there in that particular sector with that particular kind of skill sets. And then we start building bridge courses, which could then help us to move very quickly. These are short-term courses which would make the existing workforce ready and enabled for the opportunities in green hydrogen. So those short-term bridge courses is what we can start focusing on. That's an immediate way to really start getting rolling. There would be certain refresher courses, because people would already be working on hydrogen, and there are a lot of things which are there in hydrogen. Only things which are very specific to green hydrogens could be added to those refresher courses, and we can reskill those people to be ready for these opportunities that would be coming up in the green hydrogen sector. The courses that can be focused on are core skills like plumbing, electrical work, process operations, safety, engineering related to green hydrogen. So the focus, the initial could be, these are the low hanging fruits which could be pushed out very quickly to capitalize on the kind of work that has been done. It's about reskilling of the existing people in the sectors related to green hydrogen. Then the next, we look at new skilling. We look at the new entrants into this particular market. We said that, okay, there are people who are there who want to get into these things. How do we go about this? Now, the target audience could be freshers or young aspirants who want to really build careers in green hydrogen. And the course required for this target audience would be more detailed and long-term with a lot of practical and hands-on experience. So that is what we need to look at. How do we really go about designing these courses? These courses could be directed at entry, mid-level workforce, focus on core technical skills, managerial skills, and entrepreneurial skills related to green hydrogen. Because as we look at opportunities, there will be a lot of startups who would be getting up, and fresh engineers coming out of this, trying to do something new in the green hydrogen segment. So these courses could be directed towards them. This could be a 6 months to a year-long course, which makes them prepared for exploiting these opportunities. Some of the courses can even be introduced at the undergrad levels, either as a specialization or as one of the subjects over there in electrical, mechanical, or chemical engineering, where the focus only on green hydrogen. One is to really make them curious about this particular thing and create awareness about this entire opportunity in the green hydrogen sector. And finally, we are looking at building a capacity. So we have done the reskilling and the transitioning. We have initiated on the new skilling. How do we really go about building the capacity? How do we really go about ensuring that we have the required number of workforce as and when it is needed? So it could begin with even introducing topics in the school curriculum. We're talking about NEP 2020 as one part of the vocational thing. Green hydrogen could be integrated as a vocational subject in the school curriculum, where people talk about green hydrogen or clean energy segment, where we talk about green hydrogen. So that is where that awareness from the very early stages is been created. Further, we can have specialist degrees, like we're talking about mechatronics, or we're talking about very specialized courses been coming in engineering. We can have a clean tech or a clean energy kind of a undergraduate course been created, where it's in the university where people can take admissions and do a 4-year course over there. So we start building those capacities at the entry level itself. Then we can have professional courses which is focused on project management for green energy. or green hydrogen finances, safety related to green hydrogen, because that would help attract a lot of talent in this segment. We provide them with opportunities to really do a lateral entry into this particular segment. And these courses need to be continually built because this is a nascent industry. There are a lot of things that would change over time, and these changes would be really fast. So we have to really keep pace with the changes that are happening and ensure that we really build those skills well in advance before the technology reaches a maturity point. And it is essential that the industry, the government agencies, and the academia work hand in hand to achieve this particular. So having done the skill gap analysis, we built the curriculums. Now it's time to really propagate it further. So how do we go about building the trainer capacity? First, we start with identifying the right trainers. Now, who would be the right trainers to be trained? So these trainers could be from the energy segment or other relevant segments who has the relevant experience, passion for teaching, good communication skills, someone who can keep them updated about the trends. If it is difficult to find such kind of people internally, we probably will have to look outside the country and look at people who can really help us get this started. So we identify these trainers who could be the master trainers through which we learn, and then we really expand ourselves. So it's more like the multi-level marketing thing that happens, that you start with one and then keep on building teams of trainers to propagate this further. It is essential that we identify the master trainers for each skill on the defined skill map. When we do the skill mapping, we said, okay, there's a couple of skills, competencies that we need to have a master trainer for that, because that really gives sort of ownership for that trainer to say, okay, I'm only going to work and specialize in this particular area. This helps them really build a lot of knowledge and traction in that particular area, and becomes the person who can really help rest of the trainers to work along with him. The core team of master trainer will also have to work along with the curriculum designers and the content designers to ensure that the session covers both knowledge and the skill adequately. So it's not that the trainers come in later, but once the curriculum is designing to happen, we identify the trainers and let them work together, because when they work together and come up with this entire curriculum which is required for training, it really takes the curriculum to a different level, the way it has been delivered to the trainers. So after having identified the trainers, we need to train these trainers with the help of subject matter experts. Now, these subject matter experts can come from the industry, can come from the academia, or even we can look at overseas experts to come in and help us in creating an intensive training on all aspects of the green hydrogen technology. The master trainer should be well conversant with theory and practical aspects of the associated skills. So we talked saying that we would need people who are trainers who are very specific to a skill set or competencies. So they need to be very well conversant with the theory as well as the practical aspects of training. A master trainer certificate should just not include written tests. There has to be written exam, practical exam, and also a demo training session, because the delivery of training is more important to really create that impact and ensure that the students who are coming in for the training, basically the secondary trainers who are going to be there, are able to really absorb the knowledge and the skills that are there. So it has to be a thorough examination and evaluation for the master trainers, because these are the people who are going to help us propagate the entire green hydrogen skill initiative down to the last person. And again, when we talk about saying that we want to capitalize on the global opportunities, we have to have stringent measures. It is something that people look at it with aspiration and say that, okay, I want to be a master trainer for green hydrogen. That level of standards are something that we need to set. So the master trainers can then train other sets of trainers, and the secondary trainers should be there in terms of quality and quantity. So the stress is continuously about saying that we get the right people, we get the right quality of training done to ensure that we are able to really produce good skilled people to really harness this opportunity in this segment. Now, I'll come to the accreditation part when I talk about it in my future slides. So here, once we have identified the trainer, then training infrastructure is something which is important because unlike an IT, which requires just a computer lab to do it, a set of softwares, here we require a lot of capital investment to come in. So we look at what are the kind of facilities that are required. So definitely classrooms which are with all the modern teaching aids such as projectors, whiteboards, audio visuals. So that is something that would be required for most for these trainings. Laboratories, and I'm very happy that SCGJ is working on the specifications for these laboratories, because these laboratories are going to be really important in building these skills, because it is not just about learning. Knowledge part is important, but actually doing is something that we need to look at, because this laboratory needs to have all the equipments, instruments that would help them conduct experiments related to production, storage, and application. So building a laboratory is more important, and especially with the specifications that SCGJ will come up, it will give us a starting point for industries to really start setting up those training centers where they can train the people on the skills. As hydrogen, we all know, is a very volatile kind of an element because it is colorless, odorless, and highly inflammable. Safety becomes more important, and we need to really focus on the safety aspect. So any training facility need to have the safety training areas where they can start practicing the safety protocols, the emergency response procedures. So it is important that we lay down, when we create a specification for training infrastructure, we completely lay down what kind of infrastructure would be required from the classroom environment to the laboratories, and more focus on the safety aspect, because safety is going to be of prime importance when we are talking about hydrogen. Educational materials. Now, these education materials could be in terms of textbooks, e-learning content modules, or educational modules. Because if you are looking at scaling up, technology is going to play a very important role. So using e-learning is something that we need to look at, because at least on the knowledge front, it does well. Not so much on the skill front, but at least on the knowledge front, we would be able to disseminate knowledge, create awareness, at least give the basic knowledge part, and then get them to the laboratories to work on the practical aspects. So what would be the equipments that would be required? Now we'd require smaller versions of this hydrogen generation and storage systems, hydrogen fueling stations, hydrogen quality and testing, pipeline and distribution systems. Now these are various aspects across the value chain that would be required. Now sensor calibration, testing facilities, green hydrogen demonstrators, that's to how it has been produced, how it has been utilized, maintenance, repair workshop, proper safety gears, and environmental monitoring equipment. So this lab will have to be equipped with such kind of equipment which will help them really build a capability as well as capacity for a world-class training. And finally, on the technology, internet connectivity, now it's an easier, though I put a point over there. Internet connectivity is not so much of an issue, but internet connectivity is a must. Simulation softwares, because not everything would be covered in the training. You would require certain simulations where a student can look at what if scenarios, saying that what happens if this thing goes wrong, or what happens if we change certain parameters. So this is a good way to really learn in a non-hazardous kind of a situation. So the simulation softwares would be required, energy management systems would be required to manage in terms of how do we really use this energy, what kind of energy storage systems would be required, how do we really use hydrogen as an energy storage systems. And finally, even the safety training simulators, which could be there. This could be either through AR, VRs, various technologies are available now. So we can use technologies in a non-hazardous way to get people work on the safety, on the safety aspect in a non-hazardous way. So scaling up the training infrastructures, we need to follow the hub and spoke. So there could be 10, 15 centers been set up, which are the hubs, and from there we can have the spokes connected to them. The hub being something which is well equipped, and the spokes are something where a certain part is designated, and then the students are sent back to the hub for much more detailed training. We can leverage the existing ITIs and the skill development centers, both of the government facilities, the private facilities, the industry facilities. This could be leveraged to really build a skill. And I think that's one of the ways where quickly we can really build the capacity for the skills that are required. We can use universities and the corporate facilities as well. and one is to include GS2 green hydrogen courses in vocational education for schools. So that is something which we can do with the NEP. It allows you to really take up this vocational education in the school. So I think green hydrogen or green technology could be one of the vocational subjects which could be identified at the school level. We talked about the industry academia collaboration. Now, this collaboration can happen across various aspects. So research and development definitely is one of the aspects in which we can do these collaborations, where we can undertake joint research projects between academia and industry. And this can result in development of new processes, materials, solutions. Industry can throw challenges to the academia, the problems which they find it difficult to solve, and academia can really contribute with a fresh perspective and research capabilities to help solve these industry challenges. So research development, solving industry challenges, and finally industry can even help the academia as well as the government agencies with internship programs and the cooperative programs, where they can give students opportunity to work in live environments and gain some valuable experience in this particular industry. The industry academia collaboration can help in curriculum development for the training purpose, because there's a lot of knowledge available in the industry and expertise available in the academia. We can get those two together to really work on a world-class kind of a curriculum that is required for this particular skill development. The industry can do the skill development, skill validation as well. So once the skill map has been built and the first set of people have come out, they can do check out the skill validation, whether they align with the requirement of the industry. Are there any changes that need to be done? So that could be done. Equipment facility sharing, because may not be possible for everyone to really put up those equipments. The industry can really help in partnering and sharing those facilities with other training centers, which would be the IITs, the ITIs, the NCTVTs, which can help in building those equipments. And finally, this collaboration is more important from the policy and the regulation development point of view. So it could be a joint effort that can be made to influence the policy, regulation developments, and create a conducive environment. So setting up standards, incentive structures. So this is something where the industry academia collaboration can have. And also promoting sustainability. And because this commitment of industry is more important to really promote sustainability. So this is something which could be done along with the government agencies, with academia, to promote sustainability. And finally, coming to skill and accreditations, now there are various ways in this could be done, where we can look at the government agencies which are at national or regional level to define the standards. And they can work with the industry experts and educators to establish competency frameworks and oversee the accreditation process. So we already have the NSDCs, the SCGJs, the National Green Hydrogen Mission. So these agencies can help in setting up the standards that are required for various skills, and also work as the accredit the training centers that would be set up. Second is the industry associations like CII, ASSOCHAMs. They can be someone who can help in developing the certification programs which are tailored to the needs of the sector. And the association can offer expertise to identify the key skills that are required for the industry. Then educational institutes, universities, technical colleges, vocational training centers, they can offer the green hydrogen related courses and training programs. They can work with the industry partners to ensure that the curriculum meets the practical needs of the schools. So IITs, ITIs, the central universities and state universities can really work together in developing curriculum, courses, or even full-term programs for green hydrogen or clean tech, basically, so that this is something which becomes a source of input to the workforce. Certification bodies. Now we have got the UGCs, AICTEs, the NCTVTs. This independent certification bodies with expertise in skill assessment can provide certifications or exam assessments. So we can utilize this. So there's all the infrastructure has been set up. We just need to leverage those things by creating required changes in the structures, where we can look at green hydrogen becoming a part of it. Public-private partnerships or collaboration between government agencies, industry associations, educational institutes. So this would be something which could be done on a public-private partnership, where we can look at building up the certification authorities who can certify the skills. And finally, we can have third-party auditors, either like National Accreditation Board or private agencies who can be the people who can certify the entire process or certify an organization or a institute which is issuing the skill programs and doing the certifications. So this way we will be able to control the quality of the work that has been done. So basically a lot of opportunities coming up in the green hydrogen, lot of skills. Basically, we have to really go do it in a short time to have that first mover advantage where we can really start being a country which could be looked at as a green hydrogen supplier or talent supplier, equipment supplier to the world. So that was something that I wanted to share with you about how can we go about doing the skill training over here. So thank you so much for the time, and any queries I would be able to take it up.
Thank you, sir. Thank you for the
Just a minute.
excellent. Yeah,
Yeah,
yeah, ma'am.
thank you very much. Yeah. Sorry. Yeah.
Yeah, ma'am. Go ahead.
So I think there are very good comments, and I really like the skill gap analysis which you have presented. You know, it's very close to what
Ma'am, your voice is breaking. Yes.
So that was very good. And I think, let me see if there are any questions. I don't think so. There was this one question is there, that very good presentation. And Dr. Vanita Prasad has also said that the presentation was very good and she has appreciated it. These are all people who are starting to work in the hydrogen area. She's working in biological production of hydrogen, and others are also there. So see, it was so elaborate that I was learning in it, and I don't have much questions to ask, you know. So if you have if anyone from the participants would like to, one question is there from Mr. Shivram Deshpande. How can we include people with disabilities in green hydrogen? So would you like to answer?
It's a very nice question, because we're talking about equity, both in terms of gender, we're talking about diversity, and definitely there are a lot of opportunities for people with special needs coming into this segment. So when we are doing the skill mapping and the competency mapping, we can even look at which kind of jobs would be suitable for people with, like, females who can do it. We can look at people with special needs. So that is when we do the skill mapping and the competency mapping, we start putting up the personas against it and saying that who is the best person to do it. So that way we can identify the areas where we can basically, people with disabilities could be used in data analysis. They can be used in terms of even monitoring certain aspects of it. So there are a lot of opportunities. It is basically an area where we can look at everyone contributing some way or other in this particular segment. That's a detailed skill mapping and competency mapping along with the persona definitions will help us really get into who and what kind of role could be done by that person.
Yeah. There is one question by Mr. Nityanand. He says, please explain what is green hydrogen.
So green hydrogen by definition is something, because we have been using hydrogen for donkey's years now. So green hydrogen is something where we use renewable energy to create hydrogen using a process of electrolysis. Now, there's a definition which has been published now by Government of India, which says that the carbon emission should be around 2 kgs per kg of hydrogen that has been produced. Earlier, we used to say that, okay, zero emission, but now we said that, okay, at least let's go and say that 2 kgs of carbon dioxide or green gas, which has been produced per kg of hydrogen. Now, electrolysis was one of the ways that we looked at, but now with biomass coming in, there are various ways in which green hydrogen could be created. So now even the definition of green hydrogen will keep on changing. So the initial definition was hydrogen produced by using renewable energies through the process of electrolysis was called as green hydrogen.
Then we went into PEC also, no, photoelectrolytic catalysis. Yeah. In early I attended a conference on hydrogen, UNIDO conference. So there the concept was that we started with horsepower, and now if we want to end pollution, we have to go to hydrogen power. So once the carbon is not there, there will be no pollution. So, but then here when we produce hydrogen, of course, we will have some sort of emissions, and we will have some, we cannot exclude that.
Yeah, we cannot eliminate
Yeah.
carbon dioxide or carbon monoxide. We can reduce it considerably. And when I say considerably, it's by a large amount. So that is where we are so excited about green hydrogen.
Yeah. And when we use green hydrogen, or when we use hydrogen, we have no carbon. So the possibility of any emissions.
Also the byproduct is oxygen.
Water. Yeah. So how do you see this in fuel cells? Fuel cells and green hydrogen, they were doing parallel development. But I feel fuel cells, it's a device where you can use hydrogen. It is still not that developed. There's more focus on green hydrogen.
Right. So now, if you recollect, we had this bus service started in Ladakh using green hydrogen.
Yes.
Now there's talks of having a train which runs on green hydrogen. And beauty of this is that they are going to use fuel cells. Now in fuel cells, basically, what we do is that we use electricity to convert electricity into chemical energy, which is green hydrogen. And again, use chemical energy to convert back into electricity through fuel cell. Fuel cell is basically a reverse electrolysis process. So in electrolysis, we provide electric supply and get hydrogen and oxygen. Whereas in a fuel cell, we supply hydrogen, we take oxygen from the atmosphere and then generate electricity. So as green hydrogen efficiency increases, the conversion efficiency from electrical to chemical and back from chemical to electrical, the cost will come down. Even that day I was reading about this bus which has been coming up. They're saying that with one fueling, they can go up to 400 kilometers. So if we are able to...
Same thing has happened with batteries. When we were working on batteries, only 80 kilometers was the range. Now you have batteries for 300 kilometers. The range has improved. The safety has improved. The same will be with, Ballard had started a bus, in US and people used to wait for the fuel cell bus. But the hydrogen was stored on top of the bus. So that was there was no safety, this thing. I think now we have gone beyond that.
So that's an evolution process. That's the reason I say it's a very nascent industry, because I compare it to the mid-90s when we were talking about ITs and we were looking at, we were happy having a 256 KB kind of an internet connection. And today we are talking about 100 MB kind of an internet connection. So we have to go through that evolution. It may not take the same amount of time that IT took. This would be much more shorter. The concept of half-life is going to come into picture out over here.
Yeah, of course. Life cycles, yes. So I don't have any questions about the skilling part of it, though we are a skill council, but that was so elaborate and so detailed, and I learned a lot from it. So if there are no questions, I would like to thank you. I think Mr. Shubham Kumar has raised his hand. Mr. Rohit, could you give him the speaking rights? Mr. Shubham Kumar? Yeah, please.
Yes, ma'am. Sir, actually, I want to talk about if a green hydrogen is coming in India, and India has the target of 5 million metric ton of green hydrogen in 2030. So in this sector, in electrolysis process, we procure the energy from the renewable energy sources. And currently India's 2030 target is 500 gigawatt from renewable energies. From non-fossil fuel, in which renewable energy is approximately 420. And currently India's growth in energy sector is not fulfilling the demand of non-fossil fuel. Then how we can implement these energies in green hydrogen to procure the 500 million metric ton of target?
So Shubham, it's a nice question, and that is something people keep on asking, saying that we are currently short on the supply of renewable energy itself. We are not able to fulfill the energy requirement. How can we really say that we are going to produce 500 gigawatts of renewable energy going forward? So just if you look at the kind of projects that have been initiated on building new energy segments. Now, I'm not talking about the coal segments. I'm talking just about the renewable energies that have been set up. There are a lot of projects which have been in pipeline. So if you add up the total capacity, we would be close to around 300 gigawatts of energy already in the execution phase.
Yes, sir.
So I agree, it's a slow process. As I said, it is not going to be built over time. And this is a 2030. We have got 7 more years to go. And we'll start seeing those results in the next 3-4 years when we will have an explosion of renewable energies. Now, we are looking just more on the solar front. We haven't really started exploring the offshore wind segment, which is much more larger segment, which provides better efficiency of conversion. So your question is valid at this point in time, but I would say it's a matter of time before we really reach that kind of, because we are also ahead of the targets that we set for 2022. So
Okay.
that way, I think the progress is good. It is not visible. It is something we said that, okay, the foundation has been built, the building comes up later. So I think we'll wait and see. I'm very confident that we should be able to achieve those targets. In some cases, may even surpass those targets.
Yeah, I share with you this confidence because I am from the ministry and we had a very small target before this government came off. It was only 20 gigawatt. And from 20 gigawatt, we were told to do 1 lakh megawatt. So that was the initial.
Absolutely. So that's because it's a complete
the
jump that we
yeah.
are doing now.
Yeah. So the jump is immense. In fact, when we calculate, we see about 40-45% increase in the solar and wind installation. So this is there and it'll, I think so, the jump will be great and we will be able to achieve. Yeah. So I want to, if there are no questions, then I want to thank Mr. Sachin for a wonderful presentation. And it was so akin and allied to the Skill Council's, objectives and our activities that I really learned a lot from it. And I want to thank you. And I will also request you to kindly share this presentation with me.
I'll send it to Mr. Singh.
Yeah,
I'll share it with Mr. Singh.
Yeah.
Thank you so much for giving the opportunity. It was a pleasure sharing my thoughts and listening from the team. Thank you so much.
Yeah, and Mr. Singh can do the formal thanks. Thanks again.
Thank you, ma'am. Thank you very much. First, I would like to thanks to Mr. Sachin sir for accepting our invitation for this presentation. Thank you, sir, for excellent presentation. It's a very informative and knowledgeable. Hope all the participants are get benefited. Once again, thank you very much, sir, for the presentation.
Thanks.
Now I would like to thank all the participants for their valuable presence and support. Thank you very much, all of you. Finally, I'll thanks to Dhamija ma'am for his overall guidance and other things, and Mr. Rohit for the IT section. Thank you, Rohit. Thank you, ma'am.
Thank
you all.
Yeah.
Thank you so much. Have a nice day. Thanks.
Same. Have a nice day. Thank you. Bye.